Hi guys, I wasn't gonna record this video, but just in case, if you find this one helpful, that would be great. So I just decided to make one. Okay, so this one's basically just a practice. This I am not going to really explain through. I will just try to do as I do the questions or the examples. Okay, so here describe each of the transformations. So it's the 1 over 2 sitting in the front outside of the function. So this basically affects the y value, meaning it is the vertical compression by a factor of just as it is, right? 1/2. For the a value, as it is. Just for the b value, you flip it. So in this case, we have the b value of 1/2, right? So it will be then horizontal. Now, as you can see, it is less than 1, so it is horizontal stretch. It works opposite of the vertical by a factor of flip it, which is 2 over 1. Now, then last one is kind of combination of both. So in this case, we have a value of 1 over 4, which in this case is less than 1, and then b value of 3, which is more than 1. So this gives me, now this is, I'm going to use the short form. This gives me the vertical compression by a factor of 1 over 4. But at the same time, we have horizontal compression, right? Again, I told you it works in the opposite way. B is greater than 1, it gives me horizontal compression by a factor of 1 over 3. So remember, for the horizontal, it flips, okay, it flips. So let's take a look at this one. So f at x equals x, then stretch vertically by a factor of 5. So this means that our a is 5. So this is 5 f at x, which gives me just 5x, because f at x is x according to our function. Now, then stretch horizontally by a factor of 3. So again, stretch horizontally says horizontally. So that means our f at x should go through the b value transformation. So the b value in this case should be 1 over 3, right? Remember, it has to be always the opposite of it, and then x in this case. Now, then how do we implement this into our actual function? Well, remember, this 1 over 3x is actually replacing this x, since it's now 1 over 3x inside of the function. So then this will be negative 2 times then 1 over. Instead of negative 2 times x, it will be 1 over 3x. Okay? If you want to simplify, that's fine, but I don't really want you to simplify further than this. Now let's then take a look at the next one. It says stretch horizontally by a factor of 1 over 2. Well, this was supposed to be 2, not 1 over 2. So this is supposed to be 2. Okay, so that's a typo. So stretch horizontally by a factor of 2. Again, it's stretch, right? So the inside, the b value, is a reciprocal of what we have in the description. So 2, the reciprocal of it is 1 over 2. Now then x. Then it says reflected along the x-axis. So along the x-axis means that you reflected not the sideways, the vertical way. So we should have negative in the front. Okay. Now then how do we change our function according to it? Well, then it basically becomes negative. Now instead of saying x squared, it will be 1 over 2x squared. Okay, so hopefully you're okay with this. Remember, it was supposed to be x. Well, it was x before. Now then it is at 1/2 x. Okay. Now then this one. So this one, same thing, pretty much the same thing. Stretch vertically. So stretch it vertically by a factor of 1/2. Well, I'm not going to say stretch here. This is also another typo. It is the compression. Okay. So compression vertically by a factor of 1/2 means that the a value is 1/2 outside of the function. And then it says reflect along the y-axis. So y-axis means you are reflecting sideways. So it will be then negative x. Then how do I use this function notation to get the actual one? Then it is basically square root, but we have 1/2 sitting in the front, right? Now, instead of f at x, we have f at negative x, so it will be square root of negative x. Okay. Now, you may ask, but Mr. O, we cannot have negative value inside of the square root. Well, remember, in this case, we do not know whether x is positive or negative, right? So if the x is negative, then it will turn out to be a positive number, so it's okay. So in this case, obviously, the restriction is x cannot be a positive number. Now, then the rest is kind of the same thing over and over, right? So in this case, we have x squared as our main function. So this will be then y equals x squared. Now then we have negative, which is the reflection on the x-axis. And then we have 2, so that is vertical stretch by a factor of 2. Okay. Now, then if you look at this one, we have a square root, so we can say that the y equals the square root of x is our original function. Now, the negative gives me the reflection on the y-axis. Well, you have to put the x's. I'm just putting the short form here because I'm not really in enough space. Now, 1 over 4 gives me that it is horizontal stretch by a factor of the reciprocal of 1 over 4, which is then 4. Okay. Now, oh, I forgot. So this portion then will be just negative 2 f at x, and this will be f at negative 1/4 of x. Same thing, we have y equals x squared. Now I'm going to skip this part. Okay, I'm going to skip this part. You can now know how to do from here, but then the hard part can be from here to the actual function with the transformations on it. So instead of having x squared, the 3's is sitting in the front, so it will be y then equals 3. Now instead of saying f at x, it has f at 1/2 x. So instead of saying x squared, it will be 1/2 x squared. Again, you don't have to expand this. Okay. Now then, lastly, we have 1 over. So that means our base function is y equals 1 over x. Then something is directly done to the x. Now it has negative. So again, this negative means that you have reflection on the y-axis. Remember, this negative means that you're rotating horizontally. And then 3 means that it is horizontally compressed by a factor of 1 over 3. Now then, what is the function notation wise? Well, it will be then f at negative 3x. Now you may ask me, why is it 3x? Now remember, it was 1 over x to begin with as the f at x. Now instead of having x inside of the brackets, we have negative 3x that has to replace the x. So whatever that's sitting down here, which was x, now has to be inside of the function notation. Okay, so that's why it is f at negative 3x. Now, last the 3, these are actually easier than the previous one. So hopefully you can see it that this one from f at x, the green one, to the blue one, it's basically this. So, or is it this? So you have to think about it. Okay, you have to think about it. Now, if you think about it, it actually is this way that it reflected. That's why it's negative f at x. Now, same thing over there. This actually rotated this way, so it's f at negative x rather than negative f at x. Now, then what about this one? This one's a little tricky. So you have two graphs. One is this one, and the other one is the higher one. The middle one is the f at x. Now, then what has been done so that the black line becomes the red line? Okay. Well, if you take a look at it, the value is actually doubled. The value is doubled, don't you think? So it's vertically stretched by a factor of 2. So this gives me that the red one is 2 f at x. Now, so hopefully this example helps you do more, let's say, in-depth questions, a little harder, because especially this table, you were kind of going backwards. Okay, so I really want you to try this one again on your own. Okay, all right, so hopefully this helps. See you in class.